These are the 7 base quantities, or you can say basic quantities, which makes up the entire physical world around us. Every other quantity can be broken down into these quantities. Every other quantity is a combination of these quantities. These are length, mass, time, thermodynamic temperature, amount of substance, light intensity, and current. Now, a conference was held like 50 or 60 years ago, in which scientists from all over the world gathered together and decided to come up with a unit which they will use throughout the world. So there is no confusion among the units. For example, if I'm using 1 meter here, 1 meter at my place must be equal to the 1 meter in Europe, in America, in any desert. And that unit will be called the base unit. So basically they were trying to find a single unit for each base quantity, which can be used over and over again, and everyone will be using the same universal unit. For that, they obviously had to give some significance to that unit in such a manner that if aliens visit the earth and all humanity is destroyed, only one human is left. That human can explain them that what is meant by 1 meter, what is meant by 1 kg, what is meant by 1 second, what is meant by 1 Kelvin, what is meant by 1 mole, what is meant by 1 candela, and what is meant by 1 ampere. So they gave these 7 quantities their units, and those units are called base units. Length was given the unit of meter. Meter has its own significance, which we'll learn later on. Mass was given the unit of kg. Time seconds. Thermodynamic temperature Kelvin. Amount of substance was given the unit mole, mol. Light intensity was given the unit cd, which is candela. Current was given the unit a, which is ampere. Let me write it down. This is meter. This is kilogram. This is second. Now each of these base units has a very strong origin behind them. Kelvin. This is mole, mole. The unit is mole and the pronunciation is mole. This is candela. This is ampere. Now let's move on to the significance of these units. What is 1 meter? 1 meter is the distance light travels in a vacuum in this much second. 1/299792458 of a second. So this is very specific. Light travels the same speed throughout the entire universe. So even if you're on Jupiter, you can explain this 1 meter unit to a native that lives on Jupiter. Right? What if we find aliens on Jupiter, and the aliens on Jupiter will have very different life than us? For example, in Jupiter, they'll have different units. They might be measuring the lengths between their mountains by their own feet, right? And they might have varying sizes of feet. And if we go there, we'll tell them that our rocket is of size of 100 meter. Please make up a landing strip of 100 meters in diameter. So how will we explain them what does meter means? Light travels at the same speed throughout the universe. So we can easily explain them that what does 1 meter means. Now here's an issue that it says distance light travels in a vacuum in 1/299792458 of a second. So when we tell them about the meter, we'll also have to tell them about the second. Now second also has its own significance. We'll come back to that. This is 1 kg. Now 1 kg is mass of a platinum object of specific volume. It is kept in France, and that is taken as 1 kg, and every other thing is compared to this mass of platinum. Now 1 second. Understanding 1 second is quite tricky. 1 second is basically the time taken for electrons in a cesium atom to transit between two electron shells for 9 billion times. See, in cesium atom, there are more than one electron shells. So what is happening inside the oxygen atom is that electrons are jumping from this shell to this shell and then coming back. Now, the time taken for the electron to do this for 9 billion times, billion means 9 zeros. That time is termed as 1 second. When this electron has jumped 9 billion times between these two shells, we say that 1 second has passed. And it is also constant throughout the universe, wherever the cesium atom may be. It can be frozen in solid, it can be in gaseous form, it can be liquid form, wherever it may be, its electron will exhibit the same behavior. Now this number is measured by an atomic clock. Explore on this, what is atomic clock? It's quite interesting to know the functioning of an atomic clock, but you don't have to learn it. Now 1 Kelvin. 1 Kelvin is 1/273.5 temperature of the triple point of water, which is also equal to the temperature of Boomerang Nebula. First of all, what is triple point of water? Triple point of water is such a temperature at which ice, water, and steam exist together. This temperature is at a specific pressure. You don't have to learn about the exact value of the pressure here, just you'll have to understand what triple point means. Triple point means such a temperature at which steam, ice, and water vapor, steam, ice, and water, the liquid water, exists at equilibrium. The three exist together. Now, which is also equal to the temperature of the Boomerang Nebula. Nebula is formed when after a supernova. Supernova is the explosion of a star. When supernova explodes, it starts to cool down. Its center cools down extremely. It is the coldest thing in the entire universe. Now this is a Boomerang Nebula. The temperature of this nebula is -273 degrees Celsius or 0.0001 Kelvin, which is the coldest thing in the entire universe. This is what 1 Kelvin stands for. So you can easily explain to anybody that what is 1 Kelvin. It is the 1/273.5 temperature of the triple point of water, or it is also equal to the temperature of the Boomerang Nebula. Now, what is amount of substance? Amount of substance is measured in moles. Moles is the number of atoms in 12 gram of carbon-12. By saying carbon-12, I simply mean the carbon atom, which has this symbol in the periodic table. Take 12 grams of this atom, take 12 grams of this element, count the number of atoms in 12 grams of the substance, you'll come up with the value of 1 mole, which is this. This is actually 6 with 23 zeros. Right? This is also constant wherever you may be. 1 candela. 1 candela is the unit of light intensity when a source is emitting a single wavelength of frequency. This is the frequency at an intensity of 1/683 watts per solid angle. 1 ampere. 1 ampere is the unit of electric current, the basic unit of electric current. It is when this much electrons pass through a point in 1 second. All the other units are derived from these base units. These base units form the basics of the entire physics because they are of the base quantities.